Right, so I'm working on this new circuit using the DN2540, and you're not going to believe this thing, huh? So I've got the DN normally ohms, and this is my circuit I've been drawing up earlier today, my circuit diagram and everything. Now, I've got it on the breadboard at the moment. This thing's crazy. Look, it's going on and off, but I've got my battery connected to it, and I haven't got anything. It keeps going on and off. It's very sensitive. Basically, if I touch the battery terminal, it's already on right now, but if I this battery's flat, by the way. I connect my battery and I touch negative. If I touch the resistor with my finger, hang on, it came off. It picks up the slightest amount of interference, triggers it. It's so sensitive. So if I touch it on my finger and then wet my other finger, so this should turn it off. Oh, I've actually got this on the wrong end. It's supposed to be over here. Right, so if I touch the battery terminal, the negative terminal, and then touch that resistor, it just goes off. That's how sensitive this bugger is. It's really sensitive. And so connect this to the negative. This battery's only got 4 volts in it. Connect it to negative, touch the battery terminal, and touch the resistor on there, which is there. Comes back on again. Yeah, this is extremely sensitive, so I've got to keep the impedance low, otherwise it's going to be setting off. The circuit's going to misfire and it's going to trigger when I don't want it to trigger. So yeah, that's why I've been trying to keep the impedance down on it. But I mean, if I just connect one end to the gate, which is what I was doing earlier, just to the gate and nothing else, right, that's all I've got connected right now, and it's gone off. So and it's gone on again, on, off, on, off. There's nothing. It's just picking up hum in the room. Actually, that is how freaking sensitive this thing is. It just flips on and off. I've got it on DC ohms right now, as you can see. We're reading about 10 ohms or 11 ohms. Oh, look, it's just gone off again, huh? I ain't even touched it. Honestly, look, I'm not touching it, look. And it's turning on and off by itself. That is pretty awesome, actually. Yeah, brilliant. It'll certainly do what I want it to do, I should think. As long as it gets enough voltage on the input to trigger it, you know, because it won't trigger at 1.5 volts. It needs about, I think it's 1.8 volts, some minimum when I look at the PDF. I'll just take that off. Actually, let's disable it again. Oh, it's gone off by itself now. Now it's back on again. I need to turn it off. Hear it. There we go. It's off. Right. So it's extremely sensitive. Anyway, and when I turn it, when I turn my meter to 20 mega ohms, we're on the 20 mega ohm range right now. Nothing. That's pretty good, that is. Extremely high immunity to leakage. It is very, very good. Anyway, so that's going to work great on the circuit, and I've been drawing the circuit up earlier. Sorry about my jumping around with it. So I've already designed the circuit board. Oh, battery's a bit low. Actually, I need to charge it up. So this is the circuit board. I've already drawn the layout. Right. So, and I'm just going to have a think about this for a day or two. The reason for that is I want to make sure that since it's so sensitive, um, I want to make sure that it's got immunity to interference and noise. So yeah, if I just zoom it in, there it is on the screen. I've highlighted the areas. The red box is basically the output section, and the blue is the on threshold and off threshold. I don't know if you can see that too well. It's right across the room. Anyway, so I have to put some little. I've got some little capacitors I put in there actually on the input circuit, but the diodes. There are some diodes I've got on the gate. Now, I'm a bit concerned that the diodes might pick up RF, so let's have a look at this. I'll show you what I mean. So I've got this diode to send just a positive pulse to the gate. That's to trigger it on. And I've got a diode reverse bias which is going to pull it off, turn it off when it receives a signal. Now, the diodes themselves could pick up RF. So I'm going to have to think about this. I might have to. I think I'll put a capacitor to decouple it from any AC or any sharp pulses. Put a capacitor between the gate and source, just to remove any RF noise or anything. Just keep these diode leads as short as possible. I'll put a resistor between the gate and the diodes as well, which also helps to get rid of any RF. And because the impedance is so high on this thing, I could put a 1 meg resistor on the gate actually. Anyway, so just an update on the new circuit. There was nothing wrong with the other circuit, it does work, but I'm trying to keep everything small as possible. I mean, the smaller the better, and the less power consumption and everything else. And plus, if somebody else wants to build, if I get this working and everything, if somebody else says, I want to build that, I'd like to build that. Well, I'm not going to be burdening them with a load of components they don't need. So it's best to keep everything small and simple, and you know what I mean. Minimal component count means less money and everything else. So anyway, that's it. Happy New Year, everybody. A few hours into the new year. Actually, we're 4 hours and 16 minutes into the new year, so yeah.